Okay, so this is picking up on chapter 14.7, classwork number 2, part C. And so one of the first things that I do on these types of questions when I know it's a weak acid, strong base type of combination is I immediately calculate the equivalence point, because if you know where the equivalence point is, if you're not to the equivalence point, then you know to treat it as a buffer. If you're after the equivalence point, then you treat it in excess. And if it's at the equivalence point, then you treat it a totally different way. So it's usually one of the first things I did, and I did it on this problem. I just didn't put that as part of the video when I recorded 2A and 2B, but I usually do try to figure that out first. So in order to do that, I had to take however many moles of acid I have in my flask and figure out I need the exact same number of moles of KOH, because that's what the equivalence point is. It's when they're equal mole-to-mole ratio. And then I need to look at the molarity of the KOH to see what volume of that molarity I need. So I need 0.01 moles of KOH, and I'm using a 1 molar solution, 1 mole per liter, and it's most likely best to think in terms of milliliters because that's what the questions are giving us. The A, B, and C are in milliliters. So 0.01 times 1,000, which gives me a volume of 10. So at 10 milliliters of KOH, that is my equivalence point. So then I'm on this particular question at the equivalence point, which means my mole-to-mole ratio is equal. And so therefore, I'm going to plug it in to kind of a similar expression that we've seen in the past, where I first need to calculate my molarity. So I have 0.01 moles. Okay, this is equal. And then I'm going to have a new volume. Okay, so it's 0.01 moles. If I'm looking at right here. Okay, so this is, if I reuse all of mine, then I'm going to have 0.01 moles of this. Okay. Plug that into here to get my new molarity. Oh, I think I did something wrong. There we go. Okay, I typed. So it's 0.01 divided by 0.110. It's my 100 milliliters of my weak acid plus my 10 milliliters of my base. Gives me a new volume of 110. And that means the molarity of my conjugate is going to be 0.0909. So then I'm going to set up an equilibrium expression to then work back the opposite direction. 0.0909 molarity is going to then be in equilibrium with my weak acid and my OH. I'm going to have minus X plus X plus X, which gives me an equilibrium expression that I'm familiar with. And I'm going to set that equal to Ka, just like we've done so many times in the past, which gives me X squared I'm going to assume the 5% rule because I solved for X here and then divided it by this value and times it by 100, and it was less than 5%. So when I rearrange this, and this is my Ka value that I've converted from pKa using 10 to the minus pKa. And that gives me a pOH value, because I was looking at hydroxide, of 3.02. Subtract that from 14 to get pH. It's 10.98, my final answer. Now, I'm going to show you on this last little bit what I mean when I say 5% rule. So in blue, off to the side, if I solve for x and write it down, so I'm going to get 0.34. I'm going to take 1.0 times 10 to the negative fifth, multiply it by 0.0909, my molarity, and then I'm going to take the square root, and that tells me that x equals 4. X equals this. Okay, so that's what this expression equals. Then I'm going to take this number, and in green, so it's a different color, I'm going to divide that number by this number and multiply by 100. That equals 1%. Okay, so what that means is the change in x was less than 1% of that answer.